This is LLL222 Practical Phonetics by Professor Dr. Anyanwu Rose Juliet, Department of Languages and Linguistics, Nasarawa State University, Kefi. Content: Pronunciation and Transcription. Introduction, Learning Outcomes, Phonetics, Definition and Branches, Phonology Definition, the relationship between phonetics and phonology, the phoneme, classification and analysis of sounds, suprasegmental features. Pronunciation and transcription. Pronunciation is the phonic shaping of the oral form of language. This means that each time you're talking, you're shaping sounds. Speech sounds are grouped into language units called phonemes. The phoneme is realized in speech in the material form of speech sounds of different type. Various speech realizations of the phoneme are called its allophones. Transcription, in our case, is precisely the visual representation of speech sounds, or phones, by means of phonetic symbols and/or notations listed in the International Phonetic Alphabet, popularly known as the IPA chart, which is recommended by the International Phonetic Association. The session is an action plan aimed at improving your pronunciation of speech sounds and at the same time showing you how to transcribe such speech sounds, practically by means of phonetic symbols, combined sometimes with notations, some of which are often called diacritics. At the end of this session, you should be able to have an improvement in your pronunciation and should be able to transcribe speech sounds more accurately. Learning outcomes. When you have studied this session, you should be able to identify various organs of speech, which include the sagittal section, the vocal tract and its cavities containing the nasal cavity, the oral cavity, the articulators, the pharyngeal cavity, and the larynx. Identify and mention the relationship between phonetics and phonology, including similarities, differences, and interface. Differentiate between a phoneme and its allophones. And lastly, pronounce and transcribe speech sounds more accurately. Definition. Phonetics is the study of the articulatory, that is, physiological and aerodynamic, acoustic and perceptual characteristics of spoken human language. It is made up primarily of the following three branches: articulatory phonetics, acoustic phonetics, and auditory phonetics. Articulatory phonetics is the study of how speech sounds are made or articulated. Acoustic phonetics deals with the physical properties of speech as sound waves in the air, and auditory or perceptual phonetics deals with the perception via the ear of speech sounds. One other area, called forensic phonetics, has applications in legal cases involving speaker identification and the analysis of recorded utterances. Breathing versus speaking. It has been known for decades that the physiology of exhalation, that is, breathing out, is quite different from the physiology of airflow during speech. Exhalation is much faster and therefore has much higher rates of airflow than speech. During speech, air pressure is carefully controlled by a complex antagonistic interplay between the lungs and the respiratory musculature. We normally speak with air flowing outward from the lungs to the mouth and sometimes nose. That is, with the pulmonic egressive airstream mechanism. That pulmonic refers to the lungs and egressive means leaving. Although in some sounds of some languages, the airflow can briefly be changed, even reversed. The speech organs. Speech organs, compare figure 1 below, are those parts of the human body that are directly involved in the production of speech. These organs are located in the voice box or larynx and in the throat. And in the throat and mouth, that is the vocal tract. Although it is not necessary to delve here to delve into fine details of the physiology and anatomy of the individual organs, some of their linguistically pertinent properties need to be explicated, that is explained, namely the names, phonetic relevance of the main speech organs. We also need to consider the role they play in the mechanisms and processes of speech. Below you have figure 1 containing the speech organs. Here in front, foremost you have the upper and lower lips. Behind you have the upper and lower teeth. Thereafter you have the alveolar ridge, and then the tongue containing the tip, the blade, the body, and the root. Then you have the lower jaw, you have the pharynx or the pharyngeal tube, you have the larynx containing the vocal folds, and the opening between these two vocal folds is called the glottis. Then above the tongue you have your hard palate, the soft palate, the uvula, and then above the hard palate you have the nasal cavity. The tongue, the teeth, as well as the lungs were primarily not developed for the purpose of speech, and indeed each of them has some other primary function within human anatomy. Example, the lungs are for breathing, the teeth for chewing, and the tongue for swallowing. Speech organs are also referred to as articulators when they are involved in the production of any particular speech sound. The outgoing breath from the lungs is the medium through which most speech sounds are produced by the relevant speech organs. On its way through the vocal tract, this breath is modified in various ways at various stations, that is, by the different speech organs to produce individual sounds. In other words, Speaking comprises the choking and obstructing of the outward passage of expiratory air at various places in the vocal tract and in various different ways. Hence, perceived differences in speech sounds are the result and correlate of differences in the place and manner of this obstruction of airflow, and the terms and categories of phonetic description principally refer to individual aspects of this process. All speech organs are used in all human languages, but each language has preferred combinations of articulations. Therefore, it has been observed that some of the less common sounds are only found in particular areas of the world. For example, many West African languages have implosives like b, b, d, d, and g, g. In addition, linguistically relevant clicks, that is, velaric ingressive stops, are found especially in Africa. The vocal tract and its cavities. The vocal tract, see Figure 2 and compare Figure 1, is the name given to the entire space through which air from the lungs can travel during speech, extending from the larynx to the lips or nose. This space is often regarded as a tube which branches to form the three main cavities or resonance chambers. 1. The nasal cavity. 2. The oral cavity, loosely termed the mouth, and the pharyngeal cavity, loosely termed the pharynx. Figure 2 is titled Schematic Representations of the Three Cavities of the Vocal Tract. A. The location of the cavities. B. The branching tube model. The oral and pharyngeal cavities can vary in shape. The nasal cavity is unvarying in shape and very narrow, hence much smaller in volume than it might appear from these two-dimensional diagrams. On the one hand, the vocal tract serves as a complex resonator, modifying the quality of sounds. This is true especially for vowels. On the other hand, it contains articulators which are used to produce other sounds by constricting, that is, narrowing or obstructing the airflow. Such sounds are typically consonants. The nasal cavity. The nasal cavity constitutes the upper branch of the vocal tract. It participates in the production of speech sounds only when air from the pharyngeal cavity passes through it. Nothing ever happens in the nasal cavity. Example, some kind of constriction. Its activities in the production of speech are controlled by the opening and closing of its entrance by a special valve called the soft palate or velum. This entrance closes when the velum is pressed upwards and opens when the velum is allowed to hang down as in normal breathing. Sounds which are produced with the nasal cavity open, that is, which have resonance in the nasal cavity, are called nasal sounds. All other sounds are termed oral because only the oral cavity is involved in their articulation. The nasal cavity is closed and inactive. The oral cavity. The oral cavity stretches from the velum, that is the entrance to the nasal cavity, to the lips. In contrast, with the nasal cavity, the oral cavity contains movable articulators, each with a passive counterpart on the vertically opposite side of the tube. These positions of the articulators are traditionally classified longitudinally, that is, traveling along the tube, moving backwards from the lips as listed in Table 1 below. In Table 1, you will find a few examples of consonants that are made using each articulator. However, because two articulators are always involved in the production of a consonant, you will see two names in the articulators column. Note that the sounds given here as examples are for illustration only. The precise nature of each of these sounds will emerge later. For the moment, it is important to concentrate on where you produce these sounds and which speech organs are involved. Beware, in Table 1, letters such as P, B, and M refer only to the particular example given here. This does not mean that the letter or combination of letters concerned will always correspond to the same IPA symbol. The articulators in the oral cavity and example consonant. On the left-hand side, for the articulators, you have passive and active. Number 1, we have none, and as active, we have upper and lower lip. The adjective for this is bilabial. Example from English, unless otherwise stated. P as in pen, B as in ban, M as in man, F as in fan. And then you have the upper front teeth as passive articulator. The adjective for this is dental. And then you have as active articulator the lower lip, and its corresponding adjective is labial. For example, F as in fan, V as in van. These are all examples from English. And now, on the left-hand side, as a passive articulator, you have upper front teeth. The adjective for it is dental. As active articulator, you have the tip of the tongue or blade. Adjective for this is laminal. Examples are, for the voiceless one, you have f, 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 as in thin, thin. And for the voiced counterpart, you have the, as in this, or within, within. And then for the passive articulator, you have the alveolar. The adjective for it is alveolar. The active articulator is the tip or blade of the tongue. The adjective for the tip is apical, and the adjective for the blade is laminal. Examples are t as in tame, tame, and d as in dame, dame, and then n as in name, name, or s as in same, same, or z as in zebra, zebra. And then As a passive articulator, you have the hard palate, and the adjective for it is palatal. Palatal. And then you have as active articulator the body of the tongue, and the adjective for it is dorsal. Examples are from fulfulde. You have the ch, like in charon, meaning limit or boundary, or its voiced counterpart, also in fulfulde, as in Zhao, meaning bracelet, or in French, Nya, as in agneau, meaning lamb, or in German, as in ish, meaning eye, or in modern Greek, y, as in yay, meaning high, or the voiced counterpart as in English in yes, in yes. Apart from the lips, all the articulators named here in Table 1 are passive articulators, that is, they do not move. In every case, again, with the exception of the lips, it is a part of the tongue which is the active articulator. In the case of the lips, both articulators, namely the upper and the lower lip, move towards one another. The only other case where this happens is with the glottostop, where the vocal folds move towards one another. The tongue is a very important speech organ which stretches from the pharyngeal cavity right to the front of the oral cavity. It is always the active articulator. Because various different parts of the tongue are used for the production of different sounds, it is necessary to distinguish the following four parts. 1. Tongue tip, adjective apical, that is the extreme front edge of the tongue. 2. Tongue blade, adjective laminal, that is the front part of the upper surface of the tongue, just behind the tip. Number 3. Tongue body, adjective dorsal, that is the region from the blade of the tongue to the uvula. Number 4. Tongue root, adjective radical, that is the region from below the uvula to the larynx. The part of the tongue located in the pharyngeal cavity. For example, see Table 1 above and Table 2 below. Many consonant sounds are articulated by the tongue making contact with some part of the roof of the mouth. In addition, the movements of the tongue, especially the tongue body, alter the shape of the resonance chamber of the oral cavity in such a way that vowel sounds of different quality are produced. By quality, we mean differences such as between the vowels in the English words hit, head, and hood. The pharyngeal cavity. The pharyngeal cavity or pharynx is the vertical part of the vocal tract tube, stretching from the larynx up to the velum, where the tube divides and the nasal and oral cavities begin. The pharynx contains only one place of articulation. Here again, we have passive and active articulators. The passive articulator here is the pharynx. Adjective for it is pharyngeal. The active articulator is the root of the tongue. Adjective for it is radical. Examples are from Arabic and Berber. First of all, Arabic. Hamele, 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 meaning he carried. And then Berber, tahbut, 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 meaning flatbread. Again, Arabic for the voiced one. We have hain, 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 meaning eye, the eye you use in seeing. The larynx. The larynx is the lowest part of the vocal tract. It serves as a gateway for air from the lungs and contains the vocal folds. The horizontal space between the vocal folds is called the glottis. It is here that the glottal stop is produced, which can be found in place of t in many varieties of English, example London and New York. In such varieties, all the single or double t's in the sentence, what a lot of little bottles are pronounced for example, what a lot of little bottles. What a lot of little bottles. When the glottis is not completely closed, air from the lungs can pass through it vertically in an upward direction. Now, we're into phonology. First of all, the history and aims of phonology. The linguistic subdiscipline of phonology arose historically from phonetics, and therefore, in its early stages, looked almost exclusively to phonetics for its justification and inspiration. In the second half of the 20th century, phonology began to emancipate itself from phonetics and develop its own autonomous theories of sound systems. At the same time, phonologists began to attach more importance to the grammar-oriented side of phonology, that is, to morphology. The rapid development and diversification of phonological theories means that today we have a large number of quite different views on the relationship of phonology to phonetics on the one hand and to morphology on the other. Now, the phoneme and the phone. What's a phoneme? A phoneme is an abstract single distinctive sound of a language. That is, a segment which distinguishes forms, i.e., morphemes, based on which words are composed from one another. What is a phone? A phone is a phonetic segment which realizes a phoneme of a language. The phoneme. Phonemes, being phonological representations, are written between slashes. Phones are always written between phonetic square brackets. This is because only phones are pronounceable. Phonemes are abstract phonological units. A phoneme of a language must therefore have at least one phone with which it is realized phonetically, but it is more usual for a phoneme to have more than one phone because of the influence of neighboring sounds, i.e., the phonological context, also called the phonological environment. Allophones. What do we mean by allophones? When more than one phone of a phoneme exists, they are called allophones. I take that again. When more than one phone of a phoneme exists, they are called allophones. Allo comes from Greek and means different. So the allophones of a phoneme are simply the different phones with which that phoneme is realized. Ideally, phonemes and their allophones should be one to many unique phones. This means that each phone of a language should be uniquely identifiable as an allophone of one phoneme only, and conversely, that each phoneme of a language has its own exclusive set of allophones. In English, for example, the allophones of the consonant phonemes are biunique, as illustrated in Figure 1 below for the phoneme T. Here, I've used a hen to represent a phoneme and its two cheeks to represent the allophone. The first one on the left is T, T, aspirated T, and the one on the right is non-aspirated, simply T. Now, aspirated T occurs at the beginning of a word when a vowel follows, as in tick, tick, tick. Unaspirated T occurs after a word initial S when a vowel follows, as in stick, stick. So there is no aspiration. What do we mean by complementary distribution versus free variation? Complementary distribution is a term used to refer to the mutual exclusiveness of two or more allophones of a phoneme. We say that two allophones are in complementary distribution when allophone 1 never occurs in the same phonological environment as allophone 2 and vice versa. The distribution of a phone X means all the phonological positions, also called contexts or environments, in which phone X can occur. In the example of the aspirated T versus the non-aspirated T, given in Figure 1 above, these two allophones are in complementary distribution in English. This means that only the aspirated one, T, T, but never T, 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 can occur in tick and similar contexts, and only T, but never T, can occur in stick, stick, and similar contexts. What do we mean by free variation? Free variation is a condition which supplements that of complementary distribution. It can happen that two different allophones of the same phoneme occur in the same environment. When one of these allophones is replaced by the other, no new word arises. Rather, there arises a different pronunciation of the same word. In this case, the relationship between two phonetically different allophones is termed free variation. Thus, free variants, also called optional variants, are allophones which count as alternative ways of pronouncing the same phoneme. Some speakers of English, for instance, substitute a glottal stop for the T that occurs at the end of words. For example, don't or can't in the middle of words like bottle or button for bottle or button. The substitution of the glottal stop does not change the meanings. For example, if we say bottle or bottle or for bottle, all these do not contrast in meaning, nor don't or don't do not contrast in meaning. I take that again. Don't and don't do not contrast in meaning. Thus, the sounds T and are free or optional variants of the phoneme T. In these positions, they are in free variation in English. The complementary distribution test helps to determine phonemes, and the direct result being the establishment of allophones. If two sounds are phonetically similar and are in complementary distribution, this indicates that they are very likely to be allophones of the same phoneme. This test can be used, for example, in the case of vowel harmony, where minimal pairs cannot be found for language internal reasons. For example, the pseudo-minimal pair, teeth versus teeth. Clearly, teeth and teeth are different parts of speech, noun and verb respectively. They can only be regarded as a pseudo-minimal pair. Now we are into phonemic analysis. First of all, minimal pairs and minimal sets. The essential property of a phone that is an allophone of some phoneme in an utterance is that it should be distinct or differentiable from the allophones of other phonemes. Therefore, one way to discover the phonemes of a language is to look at pairs of words, which are as similar as possible, but still have different meanings. In other words, all the segments of word A should be present in the same order in word B except for one single segment. This segment is then the only sound which distinguishes word A from word B. The words A and B form a minimal pair. A minimal pair can therefore be defined as follows. A minimal pair consists of two words of a particular language which have different meanings and differ phonetically by only a single phone in the same position. According to this definition, the English words pen and ten are a minimal pair. They differ by only one single phone, namely p in pen and t in ten. The phones a and n are common to both words, and in each word, this differing phone is in the same position, namely the initial position. A minimal pair provides concrete evidence of a phonemic contrast. Thus, in the present example, we can establish that p and t are each allophones of different phonemes. If there exists more than one contrast in a particular position, all relevant word forms can be listed together. Such a list of 3 or more words, which have different meanings and differ phonetically in the same position by only a single phone, is called a minimal set. Each pair of words from a minimal set forms a minimal pair. Tip: if a minimal set can be found without too much effort, use it. This saves time and effort for both the analyst and the reader. Otherwise, use minimal pairs. Hence, the minimal pair procedure helps us to determine what phonemes actually exist in a given language. Beware, orthographic representations can sometimes be misleading. For instance, the following is not a minimal pair: bend and bank. Here, two phones change simultaneously, namely k and n, and then ng. Now we're into classification and analysis of sounds, namely vowels and consonants in selected languages. Basic vowels and consonants. The basic characteristics of vowels and consonants are dealt with in this section. Hence, this chapter's title, Basic Vowels and Consonants. This division is intended to reflect which kinds of segments can be expected in almost any language and which are less common, but it is also a practical division for the purposes of presentation. As mentioned in the preceding section, speech is traditionally regarded as a sequence of individual sounds, which are called segments. Segments are classified as either consonants or vowels. This division is, however, not always straightforward. There are segments on the vowel-consonant border, which can be problematic. In addition to the basic split between vowels and consonants, there are also subclasses of each. Furthermore, some sound features of language are best described in terms of units smaller than the segment. Example, secondary articulations, or larger example, suprasegmental features. Basic vowels and consonants. Still, the vowel-consonant distinction is a convenient starting point for the description and classification of sounds. The segmentation of the speech continuum into successive consonants and vowels is, however, an artificial process and in reality, using acoustic analysis software, quite difficult. This is because the properties of individual sounds overlap each other at slightly different points in time. Vowels and consonants are traditionally classified and described by reference to a number of articulatory factors. A consonant is characterized as a sound that is produced with some significant obstruction or hindrance in the vocal tract, including the glottis, and which normally does not form a syllabic peak, though there also exist so-called syllabic consonants. Basic vowels and consonants, their articulatory classifications. Three basic criteria for the classification of consonants are 1. Place of articulation, abbreviated POA. 2. Manner of articulation. 3. Presence stroke absence of voicing. Vowels, on the other hand, are basically classified according to the criteria 1. Frontness, corresponding to the horizontal position of the body of the tongue or tongue body. 2. Height, corresponding to the vertical position of the tongue body. 3. Roundedness, that is, the presence or absence of lip rounding. The terms height and frontness were originally proposed using slightly different terminology as articulatory descriptions of the highest position of the tongue body. They also correlate with acoustic properties of vowels. Further criteria necessary for the full description of vowels will be treated later. For the moment, we will concentrate on vowels and consonants with normal or default properties, that is, the simplest and most common segments. The acoustic analysis of vowels and consonants shows one thing very clearly. Vowels contain far more total energy than consonants. In fact, the vowel R has the highest degree of sustained energy compared to any other speech sound, while a voiceless stop consonant until it is released. All other things being equal, vowels All other things being equal, vowels have more energy than consonants, but the difference in energy between the quieter vowels and louder consonants is often very small. Also, we humans do not speak at the same monotonous volume level. We vary the relative energy in syllables. All other things we have we have had that. This is just a repetition. Now we have the English vowels. We have the short and long vowels. First of all, the short ones, starting from the front vowels. There are three front vowels there. The E, A, and the back short vowels are the O, A, and O. And the central one, the schwa, the and the long ones we have as front the E, and the back ones, the U, O, and R, and the long central one, the And then the diphthongs, the English diphthongs. We have the ear, and the and the I, and the oi, and the o, and the o, and ow, and then the a. In the articulation of consonants, a kind of noise producing obstruction is formed in the supraglottal cavities. In this table, we have the English consonants. The first line contains the voiceless ones, starting with p, t, ch, k, f, f, s, sh, h. And then the voiced ones start with a b, d, j, g, v, 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 z, j. And then m, n, l, r, w, y. Those are the voiced ones. And then the Hausa vowels. We have E, A, A, O, U with plus minus length. Now, the Hausa consonants. We have the voiceless ones, starting with the alveolar T, the palatal Ch, the velar K, and Ki and Ku as laryngeal ones. And then we have the voiced ones, the labial one, B, D, J, G. Those are the velar ones, and the Gi, and the laryngeal ones, W. And the glottalized ones, that's the implosives, B, and the D, and the G, Y, and the velar ones, K, K, and the K, and the Q. Now we are into the suprasegmental features. Suprasegments, also referred to as suprasegments, also referred to as suprasegmentals, comprise of features independent from Latin supra, on top of or above of segments. Segmental features are generally easy to determine in isolation. Segmental features are relative and determined across segments. Single suprasegmental features may occur over a single segment or over a sequence of segments. Examples of suprasegments are the syllable, length, pitch, comprising of intonation and tone, and then stress. Syllables. The majority of linguists would agree that the next higher level of phonetic and phonological structure above the segment that is composed of segments is the syllable. Unfortunately, there is no reliable phonetic definition of the syllable. The only rule of thumb that can be given is that the number of syllables in an utterance is equal to the number of syllable peaks, that is, vowels, whether monophthongs or diphthongs or syllabic consonants. A syllable peak is always more sonorous than the neighboring segments in the same syllable. However, most people have an intuitive idea of what a syllable is and are able to tap the number of syllables in a given word or phrase. The term syllable can also be defined simply as a rhythmic unit of a word. Generally, this can be done by counting the number of vowel sounds. For example, the words chair, table, computer, and computation have 1 syllable, 2 syllables, 3 syllables, and 4 syllables, respectively. Chair, table, computer, computation, whereby the syllable in bold phase is each time the most prominent, that is primary or main stress. Sounds that represent the nucleus or peak of a syllable are misleadingly called syllabic. The term nuclear would be more appropriate, but unfortunately it is hardly used. There are instances in which consonants alone can fulfill this function. The diacritic placed under a consonant denotes a syllabic consonant. Since the syllable peak is the most sonorous part of a syllable, syllabic consonants are typically those consonants with higher inherent sonority, that is sonorants, i.e. nasals, lateral approximants, and trills. Examples of syllabic nasals are found in the English words hidden and German Laden, meaning shop. Syllabic consonants may also carry tones. This is one of the easiest ways to recognize a syllabic consonant in most tone languages. For instance, Igbo, nta meaning hunting, mma meaning knife, ngu meaning salad dressing. The length of individual phones may differ. The length of a phone may depend on pragmatic reasons, phonetic or phonemic reasons, that is, to distinguish word. Non-distinctive length. In English, vowels preceding voice consonants are longer than vowels preceding voiceless consonants. For example, bead versus bit, beg versus beg. When identical phones end up adjacent to each other, they may be pronounced as a single loud, long sound. For example, 2 plus 7 versus 2 plus 8, or goes. Distinctive length. In some languages, changing the length of a phone, that is sound, can change a word's meaning. We have in Korean, mal meaning horse versus mal meaning speech. Noon meaning eyes versus noon meaning snow. In Czech, we have bit, meaning apartment, versus být, meaning to be. Dal, gave, versus dal, meaning further. In English, some vowels are pronounced longer than others. Why is this not distinctive? Answer: vowel length does not change meaning in English. Pitch. All speakers have different average pitch. A speaker's pitch may be culturally and situationally influenced. Pitch as part of language includes both intonation and tone. Intonation is pitch as it operates over phrases and sentences. Intonation does not distinguish individual words. Intonation plays a role in determining utterance meaning. Tone is pitch operating over syllables to distinguish words. Pitch is found in tone languages. Tones can be level or contour. Tone languages may use both types of tones or just one. Stress refers to prominence of a particular syllable due to increased amplitude, pitch, and length. Stress placement may be predictable or unpredictable. Predictable stress need not be memorized with words. Languages frequently have some predictable and some non-predictable stress. Predictable stress placement. In Czech, for example, stress always falls on the first syllable. In Polish, stress falls on the penultimate syllable. Non-predictable stress placement. For example, in Dutch, stress placement is sometimes distinctive. For example, voorkomen, meaning to occur, and voorkomen, meaning to prevent. In English, stress is sometimes non-predictable, sometimes predictable. Stress placement on words must be memorized in English. For example, convoy versus and convey or magazine. Stress in English distinguishes some nouns from verbs. Example, insult versus insult. Now you have an assignment for this week. Produce a phonetic transcription of the most common pronunciation you hear of the following words: she, tape, dope, walk, sigh, fell, these, thought. I repeat: she, tape, dope, walk, sigh, fell, these, thought. Thank you.